Alright, I'm gonna be real. I don't have like a script or a plan for this at all. I just have a little paper that says force and acceleration on it and a few equations underneath that. So I think instead of, going to the raw science of it, I'm going to kind of use some examples and hopefully you understand. And if not, my bad. So basically, force is how hard you gotta push or pull something. So imagine you're Batman and you just gotta, like, be Arkham Batman for a second and rock a thug's skull so hard that he forgets that he's on Earth. You know, that's just how that's force. Mass is how heavy something is. Okay, so you know how heavy a thing is in relation to gravity. So we all have a weight, and that weight would change if we were on, like, say, a different planet or in space or whatever. And acceleration is how fast or slow something's going due to the force and the mass. Okay, so the higher the force, the faster it's going to go. The only caveat to that is that no matter how hard you're pushing, it's probably going to go a little slower if it's like 800 pounds. It's just, that's the way it works. An easy way to do that kind of a calculation is that force equals mass times acceleration, or F equals m times a. And now, kind of while we're still on the topic, there's this thing called net force, and that's pretty much when two or more forces, I guess, counter each other out. And so imagine you're playing tug of war, and on the left side, they're pulling with 600 newtons, and on the right side, there's some weak little kids, and they're pulling with 100 newtons. You're gonna say, okay, what's 600 minus 100? That's 500. And so the net force is 500 to the left, which is why they're gonna pull harder. And it'd be the same if it was the opposite or a different number or whatever the difference is. That's the net force. So just a little review. Net force, difference of all the forces acting on an object. And force equals mass times acceleration. Pretty simple. Yeah, that's all.